Hello, I wanted to make a video to show you how to manipulate the the virtual lab software for lab number 9. Now, my hope is that for those of you learning at home, this lab will replace what we're going to try to do in the classroom. However, I will say from the get-go that it may be that everybody is going to have to do lab number 9 virtually, depending on how things go. So let's get started. Hopefully you can see the post for lab number 9. And I'm going to begin by clicking on the link to the enzyme activity. Okay. And what we're going to focus on here is how to set up this virtual experiment to measure the rate of an enzyme catalyzed reaction. Now, to begin, it might be helpful to look at this tab down below. It walks you through the actual reaction that's taking place as part of this virtual experiment. It's more detailed than I probably would have included had I written this, but really short and really quickly, what we're doing is using an enzyme called glucosidase to hydrolyze a bond. It's this bond here. It's one of the glycosidic bonds to release this sugar, ruteinose, from this other molecule called hesperidin. And what's unique about hesperidin is that once it's released from ruteinose, ruteinose can react with another molecule called DNS, dinitrosalicylate, to form a colored precipitate in the presence of a basic solution. So in essence, depending on how much of the ruteinose is released through this hydrolysis reaction that's catalyzed by the enzyme glucosidase, the colored product that we generate will either be yellow, that indicates there isn't a lot of, or there wasn't a lot of ruteinose present, ranging all the way up to kind of a brick red color, which indicates there is a lot of ruteinose present in the solution. So how can we actually set up an experiment in this virtual setting to measure the production of that particular product? Well, you're going to notice there are two different sliders that you can manipulate, pH and temperature. You can move the slider down, you can move the slider up for either pH or for temperature. So the first thing that you're going to want to do is choose which of these two variables that you want to manipulate. You do not need to manipulate both. You can choose which one, and you can choose how you want to manipulate that particular variable. So for example, if you chose to manipulate pH, you might start at a low value. You might change it by increments of 1 or some other increment of your choosing. But of course, that means you're going to want to keep the temperature constant. Right? A well-designed experiment only manipulates one independent variable at a time. So if you choose to manipulate pH, you want to choose a temperature at which the reaction will be held constant. If you choose temperature to manipulate as your independent variable, of course, you're going to want to you're going to want to hold the pH value as a constant. So let's just choose a couple of baseline parameters to measure. How do you set up the actual experiment? Well, you start by adding the substrate, and then the enzyme sample. And that little graphic will show up saying that the experiment is taking place. It will end on its own. Now, you want to make sure that you add that DNS. This is the chemical that will actually cause the color change inside of the cuvette, inside of the container. So we add that. And when the temperature comes back to wherever it was that you set it, 50 degrees in this case, that's when you can go over and make your measurement. And what we're measuring is the absorbance of the solution. In essence, how much light is actually able to penetrate and be absorbed by that particular solution. The higher the absorbance value, the darker the color present inside of that particular cuvette. And that's an indication, again, that lots of the particular product has been generated in the reaction. Okay, so this is the value really that you want to record after you have manipulated the variable according to your own criteria. You can record the data in the table that's included as part of the website, but honestly, I found it more useful just to go ahead and create a spreadsheet and everyone has a copy of the spreadsheet shared with them already that you can use to enter the data. So you'll see that I've already created 2 sheets, one for pH and one for temperature, with my own data. Please, please, please don't just use my data for your experiment. Design, set up, and execute your own. And then what you're going to do, whether you chose pH or temperature, is to plot the data just like I did. So for pH, we can see there is an effect of pH on the absorbance of the solution. In essence, the maximum amount of product was generated at about a pH of 9. At lower pH values or higher pH values, the amount of product decreased quite significantly. If we look at temperature, there's a temperature maximum of around 70 degrees Celsius where the largest amount of product was generated. At lower temperatures, at higher temperatures than 70 or at lower temperatures than 70, the amount of product dropped off precipitously. So we can see that there is an optimal pH and an optimal temperature for this particular enzyme based upon the experimental parameters that we set up. So you get to choose pH or temperature, collect data, plot those data. That's going to be your evidence. And from there, you should be able to use the claim evidence reasoning model to write up your lab. As always, if you have questions, don't hesitate to ask. But my hope is that this video will be helpful as you set up and conduct your own experiment.